All the charges are not moving, and we call that electrostatic. Once the charge will move, then we'll have what we call it an electric current. Movement of a charge will cause an electric current. So when we talk about current, we'll define what's current. What is current density, which is current per unit area. We'll talk about devices. So far we have talked about capacitors. We're going to talk about batteries, resistors, and this is everything in chapter 27. Then we'll talk about, capacitors are not batteries. No. Batteries provide a potential and only potential difference. But capacitors, they actually save inside them an electrical energy. I'll show you. Sometimes if you have a device that you need to provide for it a very high energy, then you have to store that energy inside the capacitor. Then you release it in a very short time. Then you get very high energy. And sometimes you want to divide the potential. You have two devices. You have a battery that's 21 volts, 20 volts, and you have two devices. Each one needs only 10 volts. What to do? Then you have to build a circuit that we call it a voltage divider using resistors to get 10 volts in here and 10 volts in here.
What some kind of thing we took resistors before? Not this.
Yes. Yes, in high school.
Physics 111 lab.
Yeah.
No. Air resistance. So this is the symbol for capacitor. This is the symbol for battery, and sometimes we do this for battery. That's the symbol for battery. And the battery, as I said, Abdullah, it's a voltage source for electromotive force. And so actually all what does the battery do is to provide a constant potential difference between 2 points. That's all what the battery do. And if you have a potential difference between 2 points, what happens to the charge? It moves from a high potential to low potential, and when the charge moves, we get current.
بس كل ده لسه البوزيتيف تشارج صح؟
Yeah. Yes. And actually, that's what happens. You have a gap that needs a charge, an electron to sit in it. So if you have an electron in here, and sitting in a gap, when it moves, then the gap has moved. So the motion of a negative charge is exactly equivalent to a motion of a positive charge in the opposite direction. So what does really move is the electron, but actually we simplify that by saying that actually it's a positive charge moves in the opposite direction. Okay?
مش هو that's what happened when they invented it in Zaman and then they built all the like that's based on one system and turned out it was wrong?
No, actually they were assuming before that actually what does really move is the positive charge, and they found later on that what does really move inside any material, it's the electrons, free electrons. Actually, positive charge does not have to be the nucleus itself, but you can have ions. So if you have an atom and you take one electron out of that atom, you get an ion, positive ion, and that can move as well. But anyway. Can you calculate that? Can you calculate that for me? That's a very good question. Can you guess how much energy do we need to break the attractive force between a positive charge and a negative charge? I will take one simple example. That's hydrogen atom. Actually, hydrogen atom. Okay. What is the force between the nucleus and an electron?
KQQ over R squared.
And so how much force do you need actually to break that bond?
KQQ over R squared.
So actually, Yeah, that's what we have explained. You remember when we had that uranium nuclei, and we actually hit that uranium nuclei by a neutron, and we split that into two nuclei, and we calculated how much energy produced by that, and it was huge energy. That's why the actual nuclear reaction can be a very good source of power if safety is taken into consideration. So we have a very small experimental nuclear reactor that's in Anshas, and as you know, we have been hearing lots about building our first nuclear power station. It's going to be somewhere in Daba, but yeah, it's on the north coast.
دكتور انا اجيب منين اصلا نيوترون عشان اخبط
there's lots of ways to actually produce neutrons, and those devices are well known now. They call them neutron sources, and there is some natural neutron sources as well. So this is not, neutrons are not the point here. The point is you have to find uranium and activate it to get that. And uranium, that's a natural material, it's exactly like oil. So if we keep on looking for uranium, after a few years, many years, we'll run out of uranium again. Like the same way we're going to run out of oil, and we're going to be looking into another source of energy. And so actually I think the only way is to look into solar energy. This is something that's renewable and it will never end. As long as there is life, there will be sun. And actually if you calculate how much energy we get every day from the sun, it's much more than what we need. The only way is to find an economical way to convert that energy into useful and electrical energy, for example.
كده عندهم كل يوم في animals بيموت وplants بيموت.
لا بس على كام سنة بقى؟
ايوه بس the rate of you using the oil is much higher than the rate. لا مش في الاخر مش هيخلص.
Okay, guys. Sham, Ala, please. Just can we just learn how to actually talk or to run a useful discussion? Since we got out of the class, I would like to use the time effectively, and we should listen at least to each other. So Ala is saying, well, oil is renewable, but actually the production rate of oil is much less than the consumption rate. So actually you cannot say that's renewable. So if you say that let's assume that we consume 1 million barrels per day nowadays, and you produce new oil by only 1 barrel per day, can you consider this is really renewable? It is. It's exactly that. Our consumption rate is much higher than the rate that actually you're getting new oil. Producing new oil. Oil is produced by under very high pressure, very high temperature. You convert coal, living trees, animals into oil, but under very high pressure and under very high temperature, and it takes very long time to do this. So actually, can we do this? Can we do an artificial oil?
No.
The answer is yes. But it's very costly to do though, because it needs energy.
So
So to produce energy, you have to use energy, much more energy. So it's not really renewable. It's exact same for water. Water is not renewable. Because there are some people will talk about how about producing hydrogen. And hydrogen is another source of energy. Hydrogen, if you burn it under the environment, it will actually combine. It will combine with oxygen and will give you water and lots of heat. But you need a lot of energy to produce the hydrogen. How come?
مش الايكو سيستم
Yeah.
بتطلع وتنزل تاني وتطلع
But if we keep actually polluting the water,
okay.
and you get acidic rain,
Yeah.
then water is not renewable anymore. So we have to actually to keep on protecting our water, not polluting it all the time. So stop polluting the environment as well.
عشان ما نجيبش
So not to preserve your water. So it's not really renewable. And how much energy do you need to produce hydrogen by electrolysis? Electrolysis, what is the electrolysis?
two plates to
Two plates, and you put between them electrical energy. So you need electrical energy to produce hydrogen. Yeah. Then you back to renewable energy, wind energy or solar energy. What's about nuclear? What? Oh, you have to get uranium actually, and uranium that's a natural ore. So you have to look for uranium to run a nuclear power station, and this is a few years, many years, you're going to run out of uranium.
It's expected that after 20 years it will.
There are theories that say that actually we are at the oil peak nowadays, and that means that we have only 50 years to run out of oil. And there are theories that say that actually we are at the oil peak, will be at the oil peak or at 2040. So there are many theories actually that we don't really know. But we are at the oil peak or we are reaching the oil peak.
the least
Yeah.
50 years.
Okay, guys, thank you for the nice break. Let's go back to business. No, that's not my class time. That's your time. And I donated my time to answer the question that's not related to the course. So if you want to actually use your time, you should have asked those questions out of the class time. Okay, guys. So, nice move. It didn't work though. Charge. Sorry. Charges, when I say charge from now on, we mean free electrons. And free electrons, they exist in any conductor. Actually, there are lots of them in a conductor. We have in any conductor something around 10 to the power 29 electron per meter cube. So each meter cube has a 10 to the power 29 electrons. Somehow, if we put that charge to move, we're going to produce electric current. And we can move that charge if we put them on a potential difference. So if you put a potential, the high potential and the low potential, then the charge will start to move. So all what we have to do is find the potential difference, and if you do so, then you get charges to move. They will move with an average velocity equal to VE, and they will have a current density, and the current density for a motion of current inside a wire equals simply that's the current divided by the cross-sectional area of that wire. So if you divide I by the area, cross-sectional area of the wire, you get what we call it current density, and that current density, which is I over A. I over A can be given by that formula, that's Q, the charge of electron, times the number of free electrons per unit volume, times the velocity of the electron.
So Q,
Q, the charge of the electron, times the number of electrons per unit volume times the velocity of those electrons.
The only variable is
Guys, if you tell me did I wrote that equation, how did I get that equation, we'll end the class. What's n? What's n? Number of what? Number of free charges per unit volume. That's n.
that's rho.
That's n.
Low rho.
No.
اللي هو number of electrons. نضرب بقى number of electrons بالcharge of 1 electron هنجيب rho. صح؟
Yeah. But yeah. So
مش الجي دي اصلا ما تاخدش جزء
what's your name? How many Omar do we have in class? Omar, there is another Omar who's not here today. Okay? Does that mean that those two are the same?
بس هي سيمبل سيمبل واحده يعني.
Does that mean that those two persons are only one person? So I can give one symbol. So I can give one symbol to two different physical quantities as long as I know, guys. Okay, you talk one more time, you get 5% negative from your grade. You too. One more time for the rest of the class. For the rest of the course, not today's class. Okay? Good. So we can assign the same symbol for two different physical quantities. As long as I know what I'm doing and I call this J as the current density, the other one that's the units for energy, then that's okay. I can call rho to be my mass, the mass density. I can call rho charge density. Does that mean that those are the same quantity? No, one of them that's mass over volume, the other one that's Q over volume. So how did we get that equation?
ادينا بس 1 minute.
Okay. Hence, a wire, long wire, and you have number of electrons that move in here, number of charges, 3 charges across that area. This is the area A. Across that distance. They travel in here, and they travel that distance x in a time t. Yes, velocity is difference over time. Shem? No. That's a good way to look at it. Thank you. You can to prove it by units, but actually I don't want that proof. You're going to prove to me that this equation is correct. Actually, I wanted to prove to them that how did we get that equation. Okay. Got it?
Doctor, having a current density is rho over
It's I over A. It's current divided by the cross-sectional area. So if this is the wire and there is current flows in here, that's I. The current density is the current I divided by that cross-sectional area. Good.
عندنا 2 areas عندنا 2 of pi r squared.
No. Okay, then what's I? I It's the change in the charge by unit per the change of time. Or delta Q over delta T. The charge per unit time. So how many charges will cross that distance x? How many charges will cross that distance x? Q. What's Q? Times A times X. Number of free electrons per unit volume times the volume. No, the volume is A. That volume is A. And that distance is X. So how many charges do we have in here? That's a number of charges per unit volume times the volume times the charge of one charge. 1 electron. Am I right? Of course right. You're going to say that it's right even if I said here it's actually equal to Omar. Please pay attention. Okay, now what's I? By dt for all of that. D by dt for all of this. N is constant. A is constant. X over T Q. So it's N E A V Q. The cross-sectional area is A. dx by dt or delta x over delta t. That's velocity. So now this is the current. What's J?
J أصلا I over A اللي هي تسمى A بجمع Q and V.
كنت عايز نطلع دي.
Okay guys, this is the end of that lecture. This is not in the slides and I will not explain it again.